Okay, so I just took a piece of heater hose. This is what is this? 5/8 heater hose. I just looped because this is what the heater core would go, and we don't have a heater core. So let's try it now with water and the alternator hooked up. And I just want to let it sit here and idle for a few minutes with the water on. All I'm going to do is just kind of feed it with a slow trickle, and then it's just going to dump out onto the ground. It's all right. It's just for a little test. It's just a little water. All right, thanks for tuning into BP Builds. So, what I've got going on here is a Speeduino ECU. So, I've been tinkering around with this for, geez, it's been a couple years now. It's April 20th, 2024, and I probably started messing around with this back in 2021. I think it was around springtime, early summer 2021. So it's been quite a while that I've just kind of been tinkering with this, but I finally got it to a point where I think I'm ready to make a video and share everything because as you can see here's kind of the finished product. And what this is this is a kind of a DIY open source ECU or PCM or ECM, whatever you want to call it, the engine control unit. It's a computer that will run basically the way it's set up currently. It would be any engine 1 through 8 cylinders. So I've basically got it set up to run a V8, specifically a Ford V8, small block Ford 302, like I have an Explorer or a Mustang or like a Fox Body or SN95, or it'll run like basically any modular motor. It'll run a 4.6 2-valve like out of a Crown Vic. So I have a lot of Crown Vic content. So I actually just got this running the way I'd like it on my little test stand today on 4.6 liter out of a '04 Grand Marquis. So that's the same firing order and same actually trigger wheel tooth for the crankshaft. Crankshaft position sensor is the same on both the 302 and the 4.6. So basically, what I'm trying to say is the computer wouldn't know the difference. If it'll run a 4.6, it'll run 302. So in this video, I think the Crown Vic fans kind of will like it because that's what the engine's going to be. That's the engine we're running. It's actually the spare engine I bought for the supercharger. So you should be seeing those videos shortly if they're not already out. But we bought an '04 Grand Marquis 4.6 liter engine just to use as a jig, like a template to mock up the supercharger during fabrication. That way I didn't have to take my car off the road. I was able to just keep the car on the road while I built the supercharger. But that engine, I never heard it run. So I figured, well, before I go ahead and modify it or start tearing the Mustang apart, let me at least prove that the ECU will run an engine and kind of do troubleshooting and learning and tinkering on a test stand rather than under the hood of a car. So the goal of the project is to install this ECU on my 1995 Mustang GT 302 pushrod V8 with a T5. It's got an 8.8 rear end with track lock with 411 gears in it. And I have a GT45 turbo kit for it, plus a set of GT40P heads and a TrickFlow Stage 1 cam and a TrickFlow upper-lower intake. So it's good to go. It's got lowering springs and upgraded sway bars and stuff like that. So it should be a good little car to have a nice small block, a nice running small block. But since I'm turboing it and since I'm changing heads and cam, the factory computer just wasn't going to handle it. It would either need a tune itself, or I chose to just make my own computer. So I wanted to kind of tinker around. I've always wanted to do this. I've always wanted to get a car running from scratch, do ECU build and my own harness and my own tune and all that. And I wanted to do that. So I just did. So, and I want to show you how to do it. And this is kind of maybe my contribution to the Speeduino community, and because I did a lot of research and learning, and I just kind of wanted to share with you what I've got. So this is the case. You can see I've got a clear plexiglass cover for it, just so you can see the flashing lights. And this is a V3.7. So this to me was, I know there's a bunch of ones out there. I just picked up a NO2C because I have plans for a smaller engine project, but I haven't built that one yet. But I chose the 0.3 because to me that was kind of like the flagship. That was kind of like the mothership. So I kind of went with that, and it's got 4 ignition channels and 4 fuel channels, so it can run a 4-cylinder, up to a 4-cylinder full sequential, which means that you're firing your one time, because it takes 2 cycles to complete a 4-cycle engine. And during that event, you have 1 injector firing and 1 spark plug firing, and if you have a 4-cylinder engine, that would mean that those things would be happening in sequence, in order. Whereas since I'm running a V8, I can't run sequential ejection. I have to run batch fire, which means that you're getting even though it takes 2 cycles to complete all 4 cycles, therefore you're going to be getting 2 spark plug events and 2 fuel injector events per engine cycle. So but you're only going to be utilizing, well, the fuel load is divided by 2, but the spark, you're wasting a spark. But that's okay because it's happening on the top dead center of it just had completed your exhaust stroke, so it's going to fire and waste that spark. There's nothing there to burn. And then when the engine comes around again, it's going to be on its compression stroke when it needs that spark. So it's sparking every rev. Just think of it just like a lawnmower. That's exactly how a lawnmower runs, or your wood chipper or whatever. So I want to go back to when I first started building this case. So this is a custom 3D printed case that I made, and it's got twist style connectors on it, and then here's the 5/32 vacuum line that goes to your intake manifold to vacuum source, and then down right there is a little Bluetooth module I'm not using, but it goes right there. So and if you haven't, there's a few other videos online that already cover that, and that's kind of what I used, plus the websites and everything. So you can figure out how to get, if you can't figure it out, let me know, but how to build the ECU itself is covered pretty well. So this is just kind of how I wanted to make kind of a more robust, reliable ECU setup that it kind of would be universal. It kind of, wherever the harness goes or wherever the ECU goes, you should be able to run that car. So I just kind of wanted to make just a generic setup here, and yeah. So let's get going with that. But the only thing notice is that I don't have those terminals with the screws. I desoldered those, and I regret even installing them, but it was handy. It was handy to get some initial testing done. So I guess I understand why they're there. It's good for tests and prototyping and your initial setup, and it's great for learning. So then I desoldered those and put, that's 20 gauge wire to some crimp terminals that we'll go over later. So let's get right into it. Okay, so in this video, I just wanted to talk about fuel rails, specifically a fuel rail from a 4.6 liter 2-valve Ford engine, but this probably would apply to more than just the Ford motors. This would be applicable to kind of any fuel rail or any fuel pump system, but I wanted to go over the differences between the 2 main styles that I've seen and worked with, and what I'm kind of doing to combine the 2 of them into one. So there's basically 2 styles of fuel rail. One of them is a pump around system, or basically the system consists of a supply line and a return line back to tank. Whereas the other system, the newer system, has simply one supply line with no return. So and in this video, and for this project, what I'm doing is I'm taking an intake manifold that is designed to run the new system, these 2 fuel rails, the single fuel line to run on an older style with the return. And the reason I'm doing that is because of the computer I'm running to test fire this motor, but that's kind of besides the point of the video. But anyway, I just kind of wanted to show you how to adapt an older fuel rail to a newer intake. But this intake manifold is off of a 2010 Crown Vic, old cop car. But this probably would apply to Mustangs as well, because the Mustangs run the 4.62 valve. So these are two fuel rails off of a newer. This is off of a 2010 or an 08. I'm not sure, or it was maybe an 06. I've had a few of these in my time, but they're all the same. And then this one is off of a 2004. And you can see that here's where the fuel line hooks up, and you can see here's where the fuel line hooks up, and there's only one. This fuel rail I got off eBay. I paid $40 for it, and this is off of an older Crown Vic. I believe this one is from a 1995, and I bought it from eBay from Texas, and it looks like it's been sitting for quite a while, and I cleaned it up and stuff, but there was some rust in the rail, which I let some CLR soak in there for a couple days and flushed it all out. But hey, just for a test, I think it's good enough. But you can see that there's a fuel line supply and a fuel line return back to tank with a regulator. So this means that on the older style, the fuel pump is simply on or off. Either it's running or it's not. And the fuel pressure inside this fuel rail, and therefore would supplied to your fuel injectors, would be controlled by the regulator. The pump is just going to run, and then this regulator is going to provide back pressure in the line, because you can see that the supply is going to go in this pipe, fill up the rail, and then it's going to go out this hose into the other bank, fill up this rail, go back to this rail, and then to the regulator. The regulator has an output. You can see there's a little bump there where it's going to grab. It's going to grab from the fuel rail. So basically everything after or downstream of this fitting is going to be pressurized, and then everything after this little bump out this hose will be unpressurized, and it's just going to be a feed back to tank. So this regulator goes to a vacuum supply, and that's pulling and pushing on a little pinto valve that's kind of throttling the fuel flow to control based off of engine vacuum. And you would, if you're running boost, you'd want to run that to a vacuum source that will see boost. But that's going to determine how the fuel pressure in the line is determined. Whereas on the newer style with only one, the way that works is with a fuel pump that's controlled. That can throttle, basically. The fuel pump can vary its output. It's controlled by the engine computer that has a PWM, a pulse width modulated signal, that's going to tell the fuel pump how hard to drive, how hard am I going to run. So if you have a high demand situation, like you have full throttle and you're towing a trailer or something like that, the fuel pump is going to run harder. It's going to run faster, which would mean the fuel pressure and the fuel flow rate are going to be higher. You can see that on the 2010 fuel rail there is no regulator. This is not a regulator. This goes to vacuum, but that's because the computer is then hooked up directly to the sensor. You see this little pigtail. This goes to the engine harness, so that the vacuum line is going to tell the computer, okay, what is my vacuum condition, which would then tell the pump how hard to run. So it's basically just replacing the mechanical regulator with an electronic sensor, essentially. And I'm interested in abandoning the newer style technology and kind of going backwards in time, because the ECU that I'm going to run to test fire this motor doesn't have the ability to control a fuel pump. All it can do is ground the fuel pump relay to turn the fuel pump on or off. So so because I have a simple fuel injection computer, I have a simple fuel injection controller, I have to run the simpler fuel injection system. So if that's your situation, this video would directly apply to you. But you can see that in order to get that to work on the Ford, On the fuel rail, you have 2 tabs, right? I had, but if you look, I had to, this is where the factory tab would be on the bottom of the fuel rail. And here on the manifold is where the fuel rail bolts to, these 2 little standoffs, this one and this one. And if I take the newer style, fuel rail, you can see that those 2 holes line up. So there's the bolt right there, and then there's the hole right there. So this is the new style. But if I compare that to the old style, you can see that if I line up this hole roughly, line up this hole roughly, these are way off. You know, yes, the fuel injectors themselves line up. You can tell that the fuel injectors themselves line up, so that's good on the cylinder intake, the cylinder head and the intake manifold. But the mounting tabs do not. So that's the issue. Plus, like I said, this is mounted on the bottom, whereas on the new rail there's like a little jog and an offset there. Plus, this older style fuel rail ran the older style injectors, the ones with the larger body with the square connector, whereas the new style uses these injectors with like the oval connector, and they're much more slender. Let me go grab a bigger injector. Yeah, here you go. Here's an older style, and you see it's got a square connector, and the body is much bigger than the newer style. But anyway, and you can also see that they're a different height. The older style is a little bit shorter. So this is a 24-pound injector out of a like a 95 Cobra, Mustang Cobra. This is a 24-pound injector out of a 2010 Crown Vic. So both 24 pounds an hour, but you can see the difference in the 2 bodies. So we're basically going to adapt. We're going to adapt the old injector and the old rail to run a new injector on the old rail on a new intake. So what I did is I cut that tab off with a cutoff wheel, and then I TIG welded a little spacer, and then I TIG welded that spacer right to the rail on the outboard side, and then the 2 left and right side, and then on the bottom I just kind of, you can see I welded just a little spacer block, and then I made a little Z bracket. So this little Z bracket is because this tab is much more to the right, much more this way than the new style is. So to get that to work, I just TIG welded 2 pieces of angle iron together, and I'm using one of the intake manifold mounting bolts. And then what I did is I took one of the bolts. Here's 2 bolts. The one on the left is unmodified, and the one on the right, you see that I cut the washer off, and then I put it in a lathe, and I just turned the little flange down a little bit. I made the flange a little bit smaller OD, so it'll grab onto so it won't bind up on the angle iron. So I just kind of wanted to show you that, and I'll show you a picture of it or a video of it when I got it all together. But I wanted to add the fuel rail from Texas. There's a hole here. It goes right through, but there was a hole here, and I was like, well, what size thread is that? And I did some research on the Mustang forum. So this is a 16th, 1/16, a 16th NPT, and then this gauge is an 1/8. So this is a 1/8 female to a 16th male NPT adapter, stainless. I think it was like $6 or something. I think I paid $9 for 2 of them just in case, so I got a spare now. But that will tell me my fuel pressure in the line, whereas the newer style rails don't have that option, because your fuel pressure would be measured by this sensor. And if you wanted to know your fuel pressure, you have to have a scan tool to tell you that. But anyway, that's kind of what I did. And then I also took 3/8 NPT pipe thread. So we got 3 different pipe threads on this manifold. And this is just a sensor for the fuel, sorry, for the coolant temp. So that's kind of what I got, and I'm going to put it together now and show you when it's done. All right, so I've got it all done, almost. I've got the fuel rails on. So you see I've got the newer style 2010 Crown Vic injectors. I think these are 08s or maybe 06s, like I said, in the old fuel rail. And you see I've got new pieces of fuel line front and back. So this is 1/4-inch fuel injection hose. Here's the part number, Duralast from AutoZone 50086. 1/4-inch fuel injection hose per SAE J30R9 for 100 PSI. So this is the fuel injection stuff. The non-fuel injection, I think, is only 50 PSI, which probably would be fine. I mean, normal fuel injection is like 39 to 45-ish PSI. But if you're running high boost, then I would get this stuff. But I've got the fuel rails just set in place. So you see there's my little Z-bar that covers, I designed it so it goes over it. So it just is an added hold down. And then there's the stock bolt. And then on the diagonal, you've got the other Z-bar that I made with the stock bolt over here. So that's how I adapted newer injectors and a newer intake manifold to run on an old pump around fuel rail. And then these are the two fittings I bought. You see that the supply side is larger, the return side is smaller. So here we go here. The supply side is larger. It's a 14 millimeter, and then the return side is smaller. It's an 11 millimeter. So this is 800. The part number is 800 131 and 800 130. I think they were something around $9 a piece or something like that. And it just has a barb fitting that you just push fuel hose onto. So that's how I'm gonna run to the fuel tank and the fuel pump. So now I'm gonna get the throttle body set up on there. So let me do that. Yeah, so I got it all back together again. I'm gonna go put it out on the car now. So I've got the throttle body elbow and throttle body on there. And I also put an EGR block off plate on. That's just a little strip of steel that I put some sealant on, because we don't need the EGR valve for this test, nor can the ECU handle one. I also linked together this vacuum line here, and then that's the the idle air control valve. So this throttle body elbow and throttle body are off an 04. So I put an 04 onto a 2010 manifold, but they're all the same, like I said. But then here, this is gonna want to tip. Here is a throttle body elbow and throttle body from the 2010. So you can see that there is no idle air control valve. It's just the motor, right? So the position of the throttle blade itself will determine your idle speed, whereas this guy has a valve that oscillates back and forth to control your idle speed. So just wanted to point that out. And when we did the supercharger, having the throttle by wire was both good and bad. It was good because it helped us, because we didn't need to fabricate any type of idle air control circuitry for the supercharger, because it was just handled by the computer anyway. So that made fabrication easy, but it made tuning a little harder. But I think that's okay. Like with everything else in life, there's pros and cons. So, okay, I guess I kind of got carried away here. I was like, man, I haven't shown any progress, but okay. So you can kind of see what I'm thinking here. I took it off the stand. Here's my flex plate that came from Georgia, because I was a dummy and I threw out the one that came with this motor. I was like, oh, what am I going to need this for? And I guess I did need it, but that one's in way nicer shape than the one that I had. But yeah, you see I got the fuel rails on, got the injectors in. Here's your supply return, throttle thermostat's in, throttle body and everything. So yeah, now I'm working on getting it on my little run stand here. And then I figured out something for the belt. I'll show you. I think it should work. I think yeah, that should work. And then I cleaned up there's, you know, your timing marks. I put like a yellow Sharpie on there or something. And then I was just test fitting the coil packs. These are a set of LS from a Chevy truck. Those are from a Silverado 5.3. So now this setup is for like a 60s big block or small block, but now I need to adapt it to this. So it looks like we got to go horizontal as opposed to 45. So I think I'm gonna take these off, save these for later, and then make a new set of wood mounts. All right, so I've got the ECU back here on the bench because there was a couple more things that I wanted to do to it. Well, two things exactly. One thing that I have been researching, and I've actually had the parts for over a year now, and I guess I don't know why I didn't do it during the build of the ECU. But you see this little module here that I added. What that's for is for a tachometer signal. I'm thinking that I'd like to maintain the stock gauge cluster on the Mustang, and that has a tachometer on it. And it would be nice to just hook, since I'm going to be abandoning the factory harness and factory computer. I'm thinking I'm going to be doing a couple splicings within the harness with a few things. One of them being the tachometer, and I'm thinking that tachometer is looking for a 12 volt trigger, a 12 volt pulse, and the main wires, you know, along this side and then along this side, there isn't a tachometer wire. But I did some searching. So someone else had already done this. Lyndon Evans. I watched his video, and it was very helpful. There is still a tachometer output on this ECU, but you have to know where to look. And it says in the wiki page, and it also says in his video that it's pin number 49. So I'm gonna rotate the ECU and see there's the Arduino Mega down there. So it's the pin right there. It's the fourth up from the bottom. So 1, 2, 3, fourth up, and then it's the outboard side, which is, you know, on the outside. So that's 49. And that's the tachometer output, but I believe that's only a 5 volt pulse. So in the video that I watched, he runs one of these opto isolator chips that I think I got this off eBay or AliExpress, or yeah, it's called A87 and A87 opto isolator. So that's what this is, and you wire on the right side, ground, the bottom one to your ground, signal ground, but on the Speeduino board, all grounds are connected to each other. So what I did is I grabbed in the proto area here, right here. See how it says 12 volts and ground? So you see 2 wires I added to the ground rail there, which is helpful, but it's nice that that's there. And so my ground here, and then there's also ground on the other side. So the 2 bottom pins go to those grounds, and then input number 1, this has 4, but we only need 1. So input number 1 is going to pin 49. And I made a little, I don't know, in the video he said made a bridge, and I was looking at what he did, and I'm like, what is that for? And his had like a little stud coming out, which the only thing I can think of is that he weaved it. He went down under where you can't see, and then looped it back up again, and made himself a little pigtail to solder onto, which I guess that was like, well, yeah, I could do that, but I'd have to take the board out of this, and I didn't want to mess with that. I just made myself a little beam there. That's just a piece of resistor. I cut the through hole lead about, I don't know, an inch long, and and just took that little bridge and soldered it to the pin 49, and then just to one of the, you have to be careful about which one you pick, because you have to make sure you're using an empty one, because the ones on the outer edges are wired to something. So let's check the schematic, but you can see I chose in the same row as 49, but the 1, 2, 3, fourth one. So I kind of made it easy. Fourth up, and then on the proto area, fourth to the left is what I did. And then that's the basically the ECU's output, or the input to this guy. And then this side is the 12 volt side. So this is going to output a 12 volts signal. So it's taking a 5 volts input and outputting a 12 volt signal. So that's pretty neat. And you're powering it with HVCC is 12 volts. 12 volts. So luckily there's, and I checked this with the multimeter. The 12 volt rail there is linked to the 12 volt in. The 12 volt in right there. See that right there, that wire. So that's getting battery voltage. So that little pin is seeing battery voltage. Ground, we just said that the ground from the battery, right here, that ground line touches, or is in contact with all of these grounds. And then your two sensor grounds on this. Or wait a minute. Yeah. Your two, well, no. Sorry. There would be a ground here and then a ground here. So they're both touching. I think this is intended to be sensor ground, but they're both wired to ground. So I guess I would recommend that you make sure that you have a nice clean ground line from your negative battery post to this device. And that way you'd be getting a nice clean ground. I wouldn't ground this to like your engine block or anything. I would run a nice clean, dedicated, brand new ground line from the negative post for this. Is what I would do. That way, like I said, you're getting all a shared ground plane, and everybody's on the same ground level. I think is what I'm trying to say. But anyway, you see that the ground, and then we just did 12 volts, and then output. So this is what you would wire to your tachometer signal wire. Usually they're green on the tach. But what I did is I said, well, I'm using all of the. I'm not using the cam sensor, but I did wire up the actual connector here, because hey, this ECU doesn't have to be ran on the engine I'm running. It can run on whatever, any engine. So I left that capability. So I don't want to mess with this. This connector, I'm basically saying, is full. There's no freedom on this. It's packed. No empty slots. But this one has 2 empty slots because of this S1 and S2. One of them is for variable valve timing, which I don't have, so that gives me 1. So that's what I did. I clipped it S1, and I just put a shrink tube just to protect it. And then I soldered in ouch to the harness, the wire going to the connector. I tied into that. So now my tachometer's outputting to this connector, and then the mating harness will get that wire. It'll be orange. Or I'm gonna have an orange tach wire, so that'll go to the gauge, hopefully on the dash. So that's basically what I wanted to show you. And here's like the little module. I don't think it was very expensive. I think it was only like maybe $6 or something like that. And then the second thing, I said there was 2 things. The second thing is I was looking. There's a fuel pump, and I tested the circuit just here on the bench. It says FP fuel pump. That will send a ground signal to a relay, just like a Bosch 30 amp relay. That would be a ground. So for a relay, you have main power in from the battery or the fuse box. Then you have main power out to the device you're powering, like in this instance, the fuel pump itself, the power for the fuel pump. Then you have switched power in. So like when the one first power one gets power all the time, the second one would only see power when the key is on. Then the last and final to get everything to work is the ground. So you're just switching with the computer, the ground on and off. And that will activate or deactivate the relay, which then turns on or turns off the fuel pump. This ECU can also do the same thing for your cooling fans for your radiator, but there isn't an output on the main pins here, but it's pin number, analog pin number 13. So you see that the bottom three on the proto area, like I was kind of saying before, this is A15, A14, and A13. So you see I just soldered in a wire in case. I'm debating if I want to sacrifice my boost control pin, or do I want to just drill a little hole here and epoxy that wire or something like that. But I don't think I'm gonna for this build. I don't think I'm gonna be running high enough boost levels that need a controller, and I think the turbo is not gonna have any problem. It's either going to be boost or no boost. so I think it's just gonna be. I think I'd be all right just running a spring with no boost controller, but I'm thinking about that. But I also can do a manual boost controller. But I don't think I need to really spend too much effort on that. But anyway, that's kind of what I wanted to show you. So this ECU is now basically finished. So here's the little chip to convert to run a two-wire. I think they're called inductive cam and crank sensors. If your cam and crank sensor has 3 wires, that's good. That's a Hall sensor. That means it outputs a square wave, which is what the computer is looking for. The two-wire devices output a sine wave, which this device converts into a square wave. So if you only have a cam and crank sensor with just 2 wires, then you got to run one of these. So this was like $19.99. And you look there, there's a little place where it goes, and it looks like a box, but the box has like a doorway on the bottom. You see there's like a pass-through. So that pass-through lines up with your little align mark, right? So do not put it this way. Don't put it that way. You gotta align the mark with the doorway. So go this way. There we go. So now that's back in there. And then this is a Bluetooth module that I tested it. It does work, but I think for my initial setup, I'm just going to run the USB. Just going to run the USB connection, and maybe later we can upgrade to the Bluetooth. So that's basically it. And I think I'll just maybe zip tie, one more zip tie, and tuck this down in there, and this will fit with the cover on. It'll be all right. It's not gonna bother anything. This is all just an empty cavity anyway. So, all right, I think that's about it. I think I've got it all buttoned up, and that's basically how my completed Speeduino ECU turned out. I'm pretty happy with it. I spent a lot of time with it, and I don't know. I think it looks pretty neat. There it is there, Speeduino the 3.7. So I think that's still the current version. I think I bought this back in 2021, and it's 2024 right now. So I'm not sure how many people are using these, but I've been tinkering with one for a couple of years, and this is where I've gotten to. And yeah, I zip tied these wires. It's crazy how dirty they got just from my fingers being a little dirty. But these other ones are nice. But yeah, there's S1 that I had just clipped, so it's still there if I ever need it again. And then there, that black one there, that's my fan wire right here. That's the fan wire in case we need it. And yeah, there's our little tach module. And then when the cover goes on, you're not gonna, the cover will just sit there, and that won't, that'll be fine. That'll be good. And yeah, so okay, so before I test, I just have to add our tachometer wire to the harness. So here's the pin that I had to crimp on, and then that's going to go pin 9 in there already. Yeah, pin 9 is the purple. Pin 10 is going to be tach. So we're going to put that in the pin 10 spot. Okay, we'll try it now. I just took the wideband out.